Assalamualaikum warahmatullahi wabarakatuh. My name is Zuhairi bin Effendy. Today I want to present about prestressed concrete. For the definition, prestressed concrete is a structural element that provides the predetermined engineering stress to be put in the components to reduce the stress that rise as they are subject to loading, and then it blends the high strength compressive properties of concrete with the high tensile strength of steel. And for normal reinforced concrete, the stress is borne by the steel reinforcement, while the prestress carries the load by means of induced stress in the entire structural element. It makes it more resistant to impact load than ordinary concrete and capable of creating long, thin structure with much smaller sectional areas to accommodate equal loads.
Basic principle of prestressed concrete. Pressure caused by high-strength steel tendons in a concrete component before load is added will balance the tension force exerted on the component during operation. And then, prestressing eliminated a range of structural limitations of traditional concrete placed on stretch and load and enables the building of floor, roof, bridge, even walls with longer unsupported stretch. Last, this enables structural engineers to develop and construct lighter and firmer structures without reducing energy.
Planning prestressed concrete. The process of prestressed concrete can be either through pre-tensioning. For pre-tensioning, placement of concrete around reinforcing tendon stress to the desired degree, and then post-tensioning. Reinforcing tendons are stretched by jet when holding them implanted during concrete curing in the voids left freehand, and then these spaces are then pumped full of grout to firmly bind steel of the concrete. Construction process. Making the prestressed concrete requires 3 steps. A. Pretension concrete. High tensile strength steel wires are mounted and lengthened and anchored into the beam portion. Next, it casts concrete around the steel and then unloaded after concrete has toughness to the required intensity.
B. Releasing the steel. The steel tendon is now trying to return to its original length, stressing itself in the concrete, which transforms the tendon into a compressive stress state. C. Transferring load to the concrete. There are 2 different types of force that are installed after loading the load end into the beam. And then the force include the internal prestressing force and the external force that balance the concrete without causing any deflection.
For the materials, first, wires. Prestressing wire is a single unit made of steel. Second, strands. 2, 3 or 7 wires are wound to form a prestressing strand. Third, tendon. A group of strands or wires are wound to form a prestressing tendon. Fourth, cable. A group of tendons form a prestressing cable. And the last one, bars. A tendon can be made up of a single steel bar. The diameter of a bar is much larger than that of a wire. Advantage and disadvantage. For the advantage, the concrete's inherent compressive strength is utilized to its fullest, and then used to the fullest degree to shape the prestressing tendons of the special alloy steel. Tension cracks are avoided, which reduce the risk of corroding steel components. The tension to the shear is reduced, and then for any given span, and loading condition, a reduction in weight can be achieved from using a component with a smaller cross-section. For this advantage, it takes a high degree of workmanship and power, and then special alloy steels are more costly than standard reinforced beton steel. And then challenge: usually use a mold that can resist the tendon force. Those are coarse layer than standard mold. For each new mix, concrete sample should be taken so that the strength obtained can be determined before the tendon are cut, which release the stress on the concrete. Because pretension can only be set once, measurement have to be right for the chamber. Therefore, it takes a lot of pre-stress, since it can only be tightened once and cannot be retightened. The builder must also take into account the grip of concrete, the elastic shortening of concrete, the shrinking of concrete, the relaxation of steel, the slip at the anchorage, and the friction losses caused by the pain and unintentional curvature in the tendon in calculation for the members chamber in order to have the structure's lasting consistency. Maintenance: suitability. Built and installed prestressed concrete framework demonstrated great performance of durability in different environmental situated. There are cases in which prestressed concrete structures tendon have experienced severely damage and degradation eons. Failure to maintain a structure may have the following consequences. First, the appearance of the structure may deteriorate, and then there may be deformation of cracking, causing concern to users or people in the vicinity, and costly or extensive work may be required at a later date or premature replacement may be needed. Last, the structure may reduce in value. Standard: high strength concrete production requires proper selection and distribution of the ingredients, careful mixing, placement and healing. And then higher cement content, low water cement material properties. Higher cement content, low water cement ratio and aggregates of good quality are required. Last, the mixture is also supplemented by a number of mineral and chemical mixtures to change the flow. Safety and health. For the policy, statement of plant or company health policy which should be written setting out specific authority lines. For the rules, the health laws are intended to help staff get hurt. And then training. All employees are trained in the training program to ensure that the safe operating procedures are implemented by all of them. Last, accident investigation. A procedure should be followed to every accident investigation. Sustainable condition. In addition to addressing the needs of environment, sustainability will also bring benefits to the economy and the society. First, sustainable friendly. Indoor air quality is important to both family and worker safety and well-being. And then a building with limited need for artificial heating and cooling can be built with a high thermal mass formwork. The formwork's durability over its lifetime ensures a smoke-free and chemical-free environment. Last, before or after the chemical treatment is not needed. Second, save money. We all know that tighter building schedules are and concurrent activities are the only way to remain ahead of the game. And then when prefabricated, just-in-time delivery eliminates dual handling and subsequent trades can get quicker. Groundworks can begin. Saving time, save money, it is easy. Third, high quality. Prefabricated manufacturing, which is produced in a factory-controlled environment, utilizes advanced technology in usable steel mold, resulting in high-quality products and less waste. Guidelines. The standards for good practice include training to keep staff healthy and safe when processing, transporting and erecting concrete precast components.
Structure of guidelines. Section 122. Establish key terms and concepts, including roles and responsibilities under HSWA. Section 3. This refers to the definition, evaluation, and control of job risk. Section 4. It briefly covers the training of workers and identifies factors that may affect the competence of workers. Section 5 to 10 cover the site management, construction, paperwork, production, handling, storage, transport, and erection.
My case study is Incheon Bridge, the new cable-stayed bridge linking the city of Incheon near Seoul and the West Coast Highway to Incheon International Airport. Is one of longest fixed line sea crossing in the world. It spans 20.3 km across the Yellow Sea, which feeders the longest cable-stayed bridge in South Korea. 800 meters long, it is built in water up to 20 meters deep and is designed to withstand the buffering of typhoon, strong winds, and the significant impact of the ship. The approach bridges are constructed from a span of 50 meters, each of which is erected as full-span precast units weighing 300 tons. Construction begin. Construction work, which began in June 2005, imposed exceptional technical criteria on all parties involved in the project. As the bridge runs over the busy main shipping route to the port of Incheon, a safe solution of maritime traffic was also required. The decision was taken to build an 8.4 km long viaduct, complemented by a 1,480 meters long cable bridge across the shipping channel. The bridge has a vertical clearance of 74 meters, a main span of 800 meters, and two side spans of 260 meters and 80 meters each. As a result, the bridge will be Korea's longest standing cable bridge and the fifth longest in the world after its planned completion in 2009. Essential foreign expertise. This adjacent to the central cable remains a segment spanning a busy shipping path. From there, traffic transferred to another 889 meter balance cantilever viaduct, which in turn links a 5.95 km twin girder viaduct to the Yeonjong side of the motorway network. And then long twin girder viaduct run across mudflats and open seas. They are resting on the piles bored into the moat. And then steel tubes were driven into the moat from 60 meters to 80 meters and excavated using reverse circulation drilling. Once the mud was out, we put in the reinforcement cage and poured the concrete, said AMEC concept engineer Kyung Min Kim. And then twin 2.4 meter diameter piles were used in the shallowest water to support the viaduct piers. The number of piles increased to a depth of up to 2.4 meter in diameter piles per pier. They are post-tension in group of 5 to mid-section of 250 meter, separated by an expansion joint, EC. The viaduct section were cast using self-coiling Italian formwork presses, the first such machine to be used in Korea. A majestic structure, and without hesitation, the hallmark portion of the bridge is the 1,480 meter steel deck cable bridge with a main span of 800 meter, the fifth longest in the world. And then the bridge deck at the magnificent 70 meter above. The water is twin inverted Y-shaped 238.5 meter height pylon, the same height as Korea's tallest skyscraper in downtown Seoul. Every one place is on top the piles cap installed on top of the 24.3 diameter piles, and then the central cable standard is prefabricated orthotropic steel bolt girder made up of 100.15 meter long segment. For the main span of the cable stay bridge, the majority of section weighed at about 300. The main span consisted of 51 small parts lifted by section of the rig crane placed on the deck, flat says. And last, the back span was completed ahead of the main span, which began at the end of February. For the extraordinary joints, the largest expansion joints link the cable stay bridge and the approach bridge and are among the largest in the world. They are also the largest mesh bar ever made and have 24 moving parts, allowing some 2000 mm of linear motion, plus side wind loading movement. And then the rubber bearings on which the cable stay bridge rests are also the largest in the world. We are made of Yokohama rubber, sandwiched with vulcanized rubber steel plates, he says. For the conclusion, between the forms of concrete such as, generally speaking, regular concrete, reinforced concrete, prestressed concrete, the best concrete is to achieve a great deal of strength in the main construction of the structure and also to enhance the lifespan of the structure. This can be used for the construction of columns, floor and bridge with a longer span and is best suited for a larger span. For overall case study, the Incheon bridge is a reinforced concrete cable bridge in South Korea. With its completion in October 2009, it became the second bridge connected between Yeonjeon Island and the mainland of Incheon. The Incheon bridge is the longest cable stayed bridge in South Korea. In addition, it is the 10th longest cable stayed bridge in the world since January 2019. That's all from me. Thank you.